During our childhood years, one of the lines, whenever we are wounded, our uncle, our mother, our friends would always say, ayaw gilakdong kay magawas ang pari. Before entering into University of Cebu, taking up nursing, one of the requirements was blood typing. I certainly believe that all of us here have touched and have seen blood. But the question really is, do we know what blood truly is? Hi, good morning. We are the Group 1. And today, we are going to be discussing all about the anatomy and as well the physiology of the blood. This is the content of our report. Today, we are going to be dealing with the characteristic and components of blood, which is the plasma and the formed elements, which are erythrocytes, leukocytes, and as well as platelets. We're going to be discussing as well the blood formation, also known as hematopoiesis, and the phases of hemostasis. And we also have the blood groups and transfusion. And lastly, we're going to be discussing about the development aspect of the blood. Now, let's first discuss about the functions of blood. The number one functions of blood is it provides the body cells with oxygen and removes carbon dioxide. Now, one of the components of blood is erythrocytes, or known as the red blood cells. Now, red blood cells contains hemoglobin, and these are protein molecules that binds to oxygen. Now, with this, it could carry or bind to oxygen and deliver it to the different body parts or body location. Now, hemoglobin also binds a little bit, no, not that much, but a little bit of carbon dioxide. So that's why as it delivers oxygen, it also reabsorbs carbon dioxide. Then it transports it into the bloodstream, to the lungs, and it is ultimately removed from the body through exhalation. Number two function of blood is blood transports nutrients and hormones. Now, blood has a component of plasma. Now, plasma is about 90% water. And it is also in here where nutrients, hormones, salt or electrolytes, and plasma proteins are actually dissolved. So it is also through blood that nutrients such as fatty acids, glucose, amino acids, vitamins that are being also transported. Now it is also here where hormones, especially those endocrine glands, since endocrine are ductless glands, so they secrete their hormones, release their hormones through the bloodstream or through the blood. And so it is also in here where blood transport nutrients and hormones through cells or different body parts or locations in our body. Another function of blood is that platelets clot blood at the site of injury. Now, platelets is another component of blood. It it helps platelets helps as well stop bleeding. So if ever there are damaged blood vessels found in the area or in certain parts of the body, platelets here helps to patch out the broken or damaged blood vessels so that the flow so it wouldn't disrupt the flow of blood throughout that blood vessel. So another function of blood is that it protects the body from pathogens. Now, there is another component of blood which is the white blood cells or the leukocytes. Now, these leukocytes form a protective or a movable army that helps the body or the immune system to be able to defend itself from bacteria, foreign bodies, viruses, and many more. The fifth function of blood is that it transports waste to the kidney and liver. Now, as blood flows throughout the body, di mo dyan na mapugnan nga di siya kabit-bit og mga waste material. Now, one of the main functions of kidney is that it filters blood. One of the functions of liver is that it removes toxins and harmful substances. Now, as blood transport these materials to kidney and as well as liver, now kidney and liver then removes this waste material from the blood. Plays a role in regulating our body temperature through vasodilation and vasoconstriction. Now, these movements now when we talk about vasodilation, it is when our body is too hot, and we are going to lowering down our temperature. Talk about vasoconstriction when we are too cold, and so we would like to increase our temperature. Now, the vasodilation now opens wide the blood vessels, and so it allows blood to enter through that, and then as the blood flows through that, it allows heat to be radiated from our blood into the air, and the blood cools down, and as well as temperature. Now, vasoconstriction is the opposite one. Now, instead of opening wide the blood vessel, it constricts and limits the blood entering from it, and then our temperature would then go up. Now, these are just some of the functions. These are just the common functions of the blood.
I'll be discussing about the composition and functions of the blood, as well as the components and physical characteristics and volume of blood. They say blood is unique. It is the only fluid tissue in the body. This means that unlike other bodily fluids, such as saliva and urine, blood is considered a connective tissue that plays a crucial role in various physiological functions. How can you say blood is a connective tissue? Blood is considered a connective tissue because it has a matrix, known as plasma, and it serves to connect various parts of the body. Blood is a connective tissue with living blood cells in a non-living fluid matrix called plasma. So in blood, may mga living blood cells. They are called RBCs, WBCs, and platelets. In turn, there are three types of WBC, the lymphocytes, monocytes, and granulocytes. And the three main types of granulocytes are the neutrophils, eosinophils, and basophils. The term non-living fluid called plasma refers to the liquid component of blood that is not composed of living cells. Plasma is a yellowish fluid that makes up the majority of blood and serves as a medium in which blood cells, nutrients, hormones, and waste products are transported throughout the body. So, nailain-lain functions ang mga living blood cells. Like the RBC, their primary function is to transport oxygen from the lungs to the rest of the body and carbon dioxide from the body to the lungs. Ang WBC help defend against the infections and foreign substances. And the platelets can assist in blood clotting. Tapos, upon separation, erythrocytes or the red blood cells form a reddish pellet at the bottom for oxygen transport. The buffy coat between erythrocytes and plasma contains leukocytes, or the white blood cells, for body protection and platelets to aid clotting. So it means that when the blood undergoes centrifugation, erythrocytes or the red blood cells settle at the bottom to form a reddish pellet. These cells are crucial for transporting oxygen. Above the erythrocyte layer, there is the buffy coat, which contains leukocytes or the white blood cells. They are responsible for the body's immune response and platelets, which aid in blood clotting. So what is centrifugation? It is the process used to separate its components based on their densities. When the blood is centrifuged, it undergoes a process called blood fractionation, resulting in the separation of various blood constituents. After that, na siya term na mag-measure sa volume percentage of red blood cells in the total volume of blood, and it is called hematocrit. Then, diyan mo makita ang percentage sa RBC, white blood cells, and the plasma. Sa RBC kay nasa 55%, and sa white blood cells kay 1% only, and sa plasma kay 55%. And contain siya og hydro. So let's go sa physical characteristics and volume. Blood is a dense, heavier than water fluid with varying colors depending on oxygen content. It has a metallic taste, slightly alkaline pH with range 7.35 to 7.45. Temperature is slightly higher than body temperature. So the pH in blood means it is the measurement of the acidity or alkalinity. So normal blood pH is around 7.35 to 7.45. A pH below 7.35 indicates acidosis, while a pH above 7.45 suggests alkalosis. So the difference between the two is that if acidosis is high, it can lead to health issues such as confusion, fatigue, and even coma. While the alkalosis may include muscle twitching, hand tremors, and nausea, and can cause by factors like prolonged vomiting or excessive intake of alkaline substances. So if you ask me why is blood warmer than the body temperature, it's because your body has exothermic chemical reactions going on in various organs. A byproduct of those chemical reactions is heat is given off and the blood absorbs the heat and redistributes it amongst the organs. So what is an exothermic chemical? An exothermic chemical reaction is a reaction that releases heat energy into its surroundings. In other words, during an exothermic reaction, the system loses energy to the surrounding environment in the form of the heat. This can result in a temperature increase in the surroundings. And that's all about the components and physical characteristics and volumes of the blood.
So what is plasma? Plasma is a 90% water-based liquid part of the blood. It contains 100 substances, including nutrients, salt, respiratory gases, hormones, plasma proteins, and waste product of cell metabolism. Plasma proteins are the most abundant solutes, with the liver producing most. So I will show you some picture of plasma or some draws that shows plasma or the percentage of plasma. So I have here a drawing that shows the percentage of plasma and the red blood cells. So the yellowish portion here is what we call plasma. And this is our red blood cells. Our red blood cells only contains 45% and our plasma is 55%. Plasma is made up of water. It is made up of, it contains 90% of water and 7% proteins. And these proteins are the albumins, globulins, and fibrinogen. And the major functions of these proteins is to give osmotic balance, pH buffering, clotting of bloods, defense, antibodies, and lipid transport. We also have here 3% others. So what is this others? So this is ions, nutrients, waste products, and gases. So we also have here the constituent of plasma. So as I've said a while ago, that plasma contains 90% of water. Now the question is, what is the function of the water in our plasma? So the major functions of the water is 90% of plasma volume solvent for carrying other substances. So it absorbs heat. So this water is the one who carry other substances, and it's also responsible to absorb heat in our body. So next we have the salts. It is sodium, potassium, calcium, magnesium, chloride, and bicarbonate. So its major function also is it is also to have the osmotic balance, to maintain the osmotic balance, pH buffering regulation of membrane, permeability. And the one that I said a while ago, the third one is plasma proteins. So, and the fourth one, the last one, is a substance transported by blood. So, what is the substance transported by blood? So, these are the nutrients that came from the food we eat every day. So, these are amino acids, vitamins, fats, sugars, fatty acids. And second one is waste product of metabolism. And the respiratory gases. The last one is the hormones. Steroids and thyroid hormone are carried by the plasma proteins. So, the first various functions of plasma in our body is first it acts as a blood buffer. So, plasma acts a blood buffer because plasma is composed of buffering systems such as carbonic acid, bicarbonate buffers, phosphate, and plasma proteins. In order to keep blood plasma within a normal range, the kidneys produce bicarbonate and excrete hydrogen ions, which aid in controlling acid base balance. And now the second one is to prevent blood loss or preventing blood loss. So a fraction of plasma high in clotting factors such as fibrinogen and factor 8 is called cryoprecipitate antihemophilic factor. By aiding in the slowing or cessation of bleeding from disease or injury, these clotting factors assist prevent blood loss. Now the question is, what is fibrinogen produced by the liver? And this protein promotes the formation of blood clots, which stops the bleeding. While the factor 8 is a coagulation cofactor produced in the liver. So coagulation factors is a collection of related proteins necessary for the production of blood clots. So both are just, helping, um, as you can see through their definition, both fibrinogen and factor 8 has the components to stop the blood loss. So the third virus function of the plasma is to protect the body from pathogens. So a subset of B lymphocytes, known as plasma cells, after undergoing terminal differentiation, release antibodies automatically. Quantity and quality of these antibodies are the best clinical correlates of vaccine efficacy, and they can offer protection against infection. So that's the three various function of plasma in our body. So now let's move on to the question, what is blood plasma used for? So plasma is commonly given to trauma, burn and shock patients as well as people with severe liver disease or multiple clotting factor. deficiencies. It also helps boost the patient's blood volume, which can prevent shock and helps with blood clotting. So again, plasma is derived in all the blood cells. Red blood cells, white blood cells, and platelets are separated from whole blood. The remaining straw-colored fluids, 90 to 92% water, but it contains critical solutes necessary for sustaining health and life. Important constituents include electrolytes such as sodium, potassium chloride, bicarbonate, magnesium, and calcium. In addition, there are trace amounts of other substances, including amino acids, vitamins, organic acids, pigments, and enzymes. Hormones such as insulin, corticosteroids, and thyroxine are secreted into the blood by endocrine system. Plasma concentrations of hormones must be carefully regulated for good health. We have is nitrogenous waste and transported to the kidneys for excretion increased markedly with renal failure. So,
So now let's discuss the form elements. Now the form elements is composed of erythrocytes, leukocytes, and as well platelets. Let's first discuss erythrocytes. Now erythrocytes occupies 45% of the blood. It is also called as red blood cells, also known as red blood cells or RBC. Now its primary function is to ferry oxygen to different parts in the body or to all cells in the body. Now um, erythrocytes are small. They are flexible cells and that shapes like a biconcave disc, flattening disc with depressed centers on both sides. It's like a donut, no? It's like it's similar. Its shape is similar, like is similar to a donut when viewed in a microscope. Now, RBC contribute or is a major contributor, the number one contributor to the blood viscosity. When we talk about blood viscosity, it talks about or measures the level of thickness and the thinness or stickiness of your blood. So if the red blood cells increase, blood viscosity or thickness increases as well. If the RBCs decreases, blood thins and flows more rapidly. Now, what's the um, what's the now one of the characteristic of erythrocytes is that is anucleate, which means to say it has no nucleus. It also lacks mitochondria. Now, during the previous discussion regarding cell, mitochondria, as we all know, is a supplier of ATP. Now, what makes erythrocytes suitable to be able to carry oxygen to different cells is that it carries oxygen if erythrocytes has mitochondria, the mitochondria itself would then eat the oxygen that the hemoglobin or the erythrocyte is carrying. Since mitochondria uses oxygen to be able to break down food, and then as the food are broken down, energy is released. No? And much of this energy escapes as heat, and but some is captured used to form ATP molecules. And so erythrocytes are really suitable for this job since it is a nucleate and it lacks energy and makes ATP by anaerobic mechanism. Now we talk about anaerobic mechanism, it's another process of making adenosine triphosphate without the use of oxygen. So erythrocytes here are literally bags of hemoglobin. So let's discuss about hemoglobin. So when we talk about hemoglobin, this is an iron-bearing protein, transport most of the oxygen that is carried in the blood. Now, hemoglobin word is actually, you know, is joined together by two words. It is heme and globin. So when we talk about heme, this is a group. This hemoglobin is a heme group that is attached to a globin. Now, so when we talk about globin, it has a four polypeptides. Now, it's made of a globin protein. It has four polypeptides. Talk about polypeptides, it's a short chains of amino acid, two or more amino acids change to combine in a regular manner to form a complex protein. So it has four polypeptides. It has a hemigroup, and the center of the hemigroup, as you've seen in the picture, is Fe. It's an element symbol for iron. Now, iron here in the hemigroup gives the ability of the hemoglobin to be able to bind to an oxygen molecules. And since, as I mentioned before, as I mentioned earlier, that globin has four polypeptides, which means to say that it has two identical alpha chain and two identical beta chain, and is capable of carrying four molecules of oxygen. So just come to think of this: one red blood cell contains 250 million hemoglobin, and each hemoglobin contains about four molecules of oxygen. That would give us a total of 1 billion, more than a billion molecules of oxygen. And that is really interesting to know. And so, um, hemoglobin. Now, hemoglobin here is also a globular protein. So when we talk about globular protein, now these are proteins that are shaped due to its specific function. So hemoglobin here is really, a suitable protein for erythrocytes for it to be able to carry oxygen. Now, RBCs, the number of RBCs are important, but then to know how well erythrocytes are functioning throughout your body, throughout your blood, is the amount of hemoglobin in the bloodstream. Now, the more hemoglobin molecules the RBC, the more oxygen they be able to carry. Now, the normal blood contains about 12 to 18 grams of hemoglobin per 100 millimeters of blood. So since hemoglobin is expressed as well in grams per deciliter. Now for men, men has 13 to 18 grams per ml for men, and for women it has 12 to 16 grams per ml. And so there are a lot of factors that contribute to the increase and decrease of hemoglobin. Now it varies. Now if it varies from age, so in infants, hemoglobin are more numerous than old people. In race, it is more numerous on white than black, since black has this, especially in the continent of Africa, it has um, it has what we call a sickle anemia, which will be discussed later on, a type of gene, and that now destroys some of the blood vessels. Now, hemoglobin varies or increases and decreases from different factors, and there's a lot. Now, for in age is a factor as well. For infants, there is numerous, no, daghan kayo sa infants ang hemoglobin. For old, less kayo. For race, no, white has more hemoglobin than black. For gender, men, no, men has 13 to 18 grams per ml for men, and for women has 12 to 16 grams per ml. It is due to that men have more higher hemoglobin than women is because of the testosterone. Now, testosterone prevents hepcidin secretion, now a peptide that regulates iron absorption. So, as it um, prevents these peptide that absorbs iron, since iron is a component in in hemigroup, now that helps bind oxygen molecules, and so testosterone prevents it. No, it then causes more hemoglobin to build up. And now, in gender, so gender check na, so diet. So it really depends on the diet of a certain person. So food rich in iron, such as red meat, poultry, and seafood, and as well vitamin C, helps absorb actually iron. And so if you incorporate iron in your diet, then you would likely more to have a hemoglobin, and you more hemoglobin, and you would somehow prevent yourself from having anemia. Next is altitude. Now let's go back to the topic of negative feedback now mechanism. So your body makes certain initiative based on the given changes in your body. Now, so if you live in high altitude, especially in mountain barangays or very on the tip of the mountain, as the altitude goes up, oxygen as well decreases. So as the body sees that niubos ang oxygen, So mumake jud nag initiative ang utok nga kini ubos mong oxygen, sige akong padagag hemoglobin kay since hemoglobin carries oxygen man. So it depends on the altitude or where you live or what place do you go. And so if less mas taas ang altitude, then musaka jud ang imuhang hemoglobin. Now next is the physical activity. Since kuan man, when talk about exercises, physical activities, you need much more oxygen. And so as your body sees nga, uy, kinahanglan man ni siya oxygen because your muscles use up most of your oxygen while doing exercises. And so the red blood cells or the hemoglobin, your body tells. Now, these are just some of the factors that contribute to the hemoglobin. So moving on, let's discuss of the homeostatic imbalance of hemoglobin, which is the anemia.